Hello, fellow chemists. Jolly here again. Let's do another one of those multi-spectra problem. Let's do number 6. So here we are with our proton NMR, and it looks like we have A, B, C, and D. It looks like we have 1, 2, 3. We have 4 peaks. So 4 unique types of hydrogens, and 2, 3, 4, and 10 hydrogens, which means there's no nitrogen or halogen. Alright, what does this look like? Pretty much looks like a doublet to me. That looks like a singlet. That is a multiplet. Still looks like a doublet. Okay, so there's not a peak over here for me to say a triplet. So those are my best guesses there. So I have a doublet that integrates for 2 hydrogens. And where am I at? Between 3 and 4, so 3.4. Oh, to me that says I'm next to an oxygen or somebody electronegative. B is a singlet that integrates for 1 hydrogen, around 2.1. And then C, I've got a multiplet that integrates for 1 hydrogen. The center of that is about 1.7. And then D, I have a doublet that integrates for 6 hydrogens, and that is about 0.9. Alright, let's do some interpretation. Alright, this is definitely my electronegative world. So a doublet that integrates for 2. So a CH2 that is connected to a CH. Okay, so a CH2 that is connected to a CH. And remember, this has to be connected to somebody electronegative. Alright, I like that. I have a singlet that integrates for 1. Alright, singlets integrating for 1 can be CHs, but don't forget, they can be OHs and NHs, but because I know there's no nitrogen, I'm going to go with the OH option right now. Keep in mind, I'm not going to fall in love with it, that's the most logical. Alright, the multiplet's not going to help me at all, but a doublet that integrates for 6, remember this is from one of the past ones, that screams isopropyl. That screams isopropyl. Oh look, that's a CH and that's a CH. Oh, you know what? I'm just going to keep going right here because it's given me some good pieces. CH3, CH, and that CH has to be connected to a CH2, which I believe is connected to an OH. Does that give me a multiplet that would integrate for 1? Oh, yep, that would give me a multiplet that integrated for 1. Huh, that might be the structure, and we haven't even gone anywhere else. Let's double check. I believe this should be a doublet that integrates for 6, somewhere between 0 and 1. This should be a multiplet that integrates for 1, somewhere between 1 and 2. And this should be a doublet that integrates for 2 hydrogens, somewhere between 3 and 4. And this should be a singlet that integrates for 1 hydrogen. Yep, that's a 1. And it should be pretty much anywhere it wants, but usually somewhere between 2 and 4. And guess what? That is our structure. That is our structure. I'll change colors here. Alright, so we have got, these guys are D. We've got C right there. We have got the singlet, which is B. A is the doublet that integrates for 2. And that is A. So A, B, C, and D. Alright, that works. Alright, let's go to our carbon 13 now. Let's see what it says to us. Oh, look. A, B, C. There's only 3 peaks, so that means there's only 3 unique types of carbons. This is the sp3 world, and this is some kind of shifting. Alright, because I predicted this already, let me just draw this and double check it here. Alright, the one furthest downfield would be right there. This one happens to be shorter and further shifted, and then these would be, see? Alright, that works pretty nice too. Oh, right there. OH. sp3. And nothing else. Now notice that is there. But of course it's there. There is a carbon-oxygen bond when you have an alcohol. Alright? So I believe I have an alcohol. And let's go to our mass spec. Maybe that little peak down there. Maybe this peak right here. Okay, so 71, 2, 3, and 4, or 91. I know from the previous ones that there is no nitrogen, so it must be this one. So my molecular weight is equal to 74. Now, if you'll notice, I keep using this mass spec last. You can use it first to give you a ballpark formula and then go. It just depends on what you're most comfortable with. All right, I know there was an oxygen in there, so I'm going to subtract 1 oxygen. So that leaves me, I should learn not to do these in my head, so that leaves me 58. And that looks like, I don't know, 4 carbons. And that leaves me 10 hydrogens. And so I would have C4H10O, and 2 times 4 plus 2 is 10, and I have 10, so 0, so there can be no pies or rings. And so I have C4H10O. Let's go check with my proton NMR. And, whoops, too far. Right there. Oh, 10 hydrogens. And C4, 1, 2, 3, and 4, H10, and O. All right, that is our structure. All right, until next time, jolly.